Hello, good afternoon. My name is Gregory Bellino, and I will be presenting a short little lesson on life science in the environment. For today's lesson, our learning objective is calculating CO2 savings. So I had a thought of perhaps, well, since we're in an urban center, uh, with all these tall buildings, they all have water towers. So we're already pumping the water up into the tower, but on the way down, what's to say that we couldn't retrofit the building so that the water, as it goes down the building, turns a turbine and produces electricity. So here is our water turbine. Okay. Also, we'll be studying moles today, moles of carbon, moles of oxygen, and moles of CO2. Some questions that we can ask ourselves are, how does burning coal impact oxygen supplies in the air? And how can cities replenish their O2 supplies? Also, why does 1 pound of coal release a greater weight of CO2? What else is reacting with the carbon? Okay, so for our givens, 1 pound of coal releases 100 watts or 1,000 watts or 1,000 joules per second of energy. But 2.07 pounds, a little over 2 pounds of CO2 emissions are released when we burn that coal. Why is that? Also, another given is our generator will release 3,000 joules per second or 3,000 watts when in use. Okay, so I have the chemical formula for bituminous coal, and I'll write it on the board right now. Excuse me, bear with me for 1 second. Okay, so this is the chemical formula for coal. As you can see, there are 137 carbon atoms, 97 hydrogen atoms, 9 oxygen atoms, a nitrogen atom, and a sulfur atom. This is why when you hear about the ill health effects of burning coal, when you burn the coal, the oxygen reacts with the sulfur, creating sulfur dioxide, which of course is poisonous. Now, this is rather complicated and way above our class. So for simplicity, we'll just work for this. We'll work with this formula. So we have our carbon plus our oxygen molecule, and this is a gas, of course, and that produces CO2 gas. Okay, now we also have 1 pound of carbon, and that should be about 36 kilograms of coal. Let me change colors. Excuse me. Okay. Better color. Let me just go back to the red. One pound of carbon equals 0.4536 kilograms carbon, and then 2.3 pounds oxygen is 1.0433 kilograms CO2. Okay, now I'm not sure how advanced this class will be in terms of moles, but you take 0.4536 kilograms carbon divided by the AMUs, 12.0107 AMUs. That equals 0.0326 moles. Carbon. Oh, sorry, wrong numbers. Yep. 78 moles carbon. And then likewise, with oxygen, we get 1.433 kilograms over 32.0000 AMUs. That equals 0.0326 moles oxygen, and then fraction measure 0.9390, because one of our givens, if I didn't state earlier, is that when we burn a pound of coal, we get about a little over 2 pounds of CO2, so quite a lot of CO2. And you may be wondering to yourself, why is that? Why is 1 pound of coal leading to way more CO2? And it's really by this equation. The carbon is in reacting with the oxygen, creating that extra weight in the CO2. And so we get, going back to our moles, and then 4.0107. So for those who are familiar with the periodic table and AMUs, the weight, the AMUs of a single carbon atom is just its molecular weight, so that's 12. With oxygen, it's 32. And with CO2, it's 44.0107. Okay, and that gives us 0.02134 moles CO2. Okay. So let this be a little foreshadowing for chemistry. We have our weights, kilograms, 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 and then our AMUs, and then convert the moles accordingly. Okay, now a little bit of physics. Let me just erase the board. Okay. And we can blue marker. Where's that? Here. All right. Okay. So here's some physics, just a little bit. Got my new marker. Yeah. So our generator from before. Okay. Turbine produces 3,000 watts, and watt equals a joule per second, and 1 pound coal produces 1,000 watts. Okay, so as you can see, there's a lot of efficiency with the water turbines. And since so many buildings in New York City are very tall and have these water towers, if we could, get some of these more turbines into these buildings, we could probably save a lot of CO2. Let's see how much. Okay. So basically, one turbine can replace 3 pounds of coal within an hour. And I'll put T for turbine equals 3 pounds coal in an hour. Okay. And so, times both sides by 24. And that equals 72 pounds of coal for one turbine. Now you could probably put several of these in one building alone, but that's not too shabby. And so, when we're thinking about the environment, our communities, and the needs to tackle climate change, we have a lot to work with. I think one of the silver linings in all this is that it's really until recently that we started thinking about the environment, about energy in unique and novel and creative ways. So not only could we add solar panels to all these buildings, we could probably stick in some turbines and decrease our CO2 emissions even further. Thank you, and have a good day.